Hi students, welcome to the problem solving session on half-wave dipole antenna. The question is an electric field strength of 10 microvolt per meter is to be measured at an observation point. Theta is equal to pi by 2, 500 kilometer away from the half-wave dipole antenna in an air at 50 megahertz. So 10 microvolt per meter. So you see our antenna is here, right? So from here 500 kilometer, 500 into 10 power 3 meter. Here 10 microvolt per meter, right? Electric field, this should be measured. Theta is equal to pi by 2, right? The antenna operates at a frequency of 50 megahertz. So 50 into 10 power 6. Now the question is, what is the first question? What is the length of the dipole? Right, so what is lambda by 2? First question is lambda by 2 because it's half a dipole antenna they told. So what is the length of the dipole means I have to find what is lambda by 2. First question. Second question is what is the thing? Calculate the current that must be fed to the antenna. So next IM value we have to find. Third one, what is the power radiated? These are all the questions, right? So first to find the length of the antenna, lambda by 2. Lambda is given by C by F. C is velocity of EM wave, 3 into 10 power minus 8, 10 power 8. F is 10 in 50 into 10 power 6. So lambda is 6 meter. So what is the length of the antenna? The length of the antenna must be equal to lambda by 2, 3 meter. So this should be 3 meter. Lambda by 2. First point we found. Next what I have to find? I maximum. What is the current? Right? So current we can find from E value only because E only they have given. E is equal to 6 microvolt per meter. For half a dipole antenna, what is E theta value? E theta is given by eta Im cos pi by 2 cos theta divided by 2 pi r. How much? What is the value of electric field produced? 5 into 10 power 6 minus 12, 10 microvolt. So 10 into 10 power minus eta is 120 pi. Im I have to find cos pi by 2. Cos pi by 2 into, again theta is pi by 2 they have given. 2 pi into r. R is 500 kilometers. So 500 into 10 power 3 meter. From this, if we simplify, cos pi by 2 is 0, cos 0 1. So this will become 1. So what you get is 83.33 milliampere. Right? So this is what IM value. We know what is R radiation for half a day. Third question is power radiated we have to find. Power radiated is, we know it is 1 by 2 Im squared R radiation. Simple, right? So IR that is equal to IRMS square divided into R radiation. IRMS I can write as Imax by root 2, so Imax squared by root 2. So 1 by 2 Imax I know 83.33, R radiation is 73 ohm for half a dipole antenna. So this will give power radiated is given by 253.5 milliwatts. So in order to produce 10 microvolt per meter at a distance of 500 kilometer, the antenna should carry a current of 83.33 milliampere, and it should radiate a power of 253.5 milliwatts. Then only it will produce 10 microvolt per meter at the distance of 500 kilometer. This is what R value. Okay, this is I value. This is electric field, right? I hope you understand this concept. If you have any doubt, please ask me in comment section. I will clarify. Thank you.